So in this video, we're going to be doing an introduction on piecewise functions. And so to start, we're going to talk about point slope form real quick. As you may recall from previous math classes, point slope form is y minus y1 is equal to m times x minus x1. But moving forward in this class, we're actually going to want to rewrite that as y is equal to m times x minus x1 plus y1. So essentially all we're doing is we're moving over the y1 to the other side. And the reason why we're doing that is because if you can also recall from previous classes, this now looks very similar to vertex form for a parabola, which would be y is equal to a times x minus h squared plus k. So just having some similarities across the board makes things a little bit more familiar. What we have is an example of a piecewise graph, and what we're going to do is create a story that matches the graph and also going to label the axes. The story I wrote is LeBron is going on a hike. He climbs for 4 minutes and then takes a break for 6 minutes. He starts climbing again, this time at a slightly faster rate for 3 minutes. Once he hits the peak at 13 minutes, he instantly starts to descend for 7 minutes. So I've labeled my x-axis in time being in minutes, and then my y-axis is feet in hundreds. So if we were to write a function to match each part of our graph, how many functions would we write? Well, we can split that up based off the different parts of our graph. So the first part is when LeBron starts his climb. The second part would be when LeBron is taking a break. The third part is when he starts climbing again and he goes a little bit faster. And then the last part would be when he's descending. So we can see we can write 4 different functions here. Now that we've identified that we're going to have 4 different functions, we can write one big function or a piecewise function in corresponding domains for each section of the graph. So essentially what we're going to do is we're going to write a piecewise function here. A piecewise function, we're going to start with an f of x representing our function is going to be equal to, then this large bracket, and this here is going to indicate that we have a piecewise function. So here's where we're going to write our 4 different functions. So let's go look back up at our graph real quick. So this first section here, this is a straight line, and we see it has a slope of 1 and a y-intercept of 0. So we can just simply write that as just x. Now, we think about the domain. We start at 0 when LeBron is starting his climb in 0 minutes, and he climbs for 4 minutes, so we go from 0 to 4. So for our domain, I'm going to write that as 0 is less than or equal to x is less than or equal to 4. So that's our first section. Now let's go ahead and look at our second section. Our second section is where LeBron takes his break. And so that break lasts for 6 minutes. And we can see this is just a horizontal line with a slope of 0. And when we have a horizontal line like that, we just write what the y value is. And this y value here is 4. So this second function is just going to be the number 4. And again, this 4 is going to go from 4 minutes all the way to 10 minutes. So that's going to be the domain for that section. So the way I'm going to write that is 4 is less than x is less than or equal to 10. Now, one thing to keep in mind here is that I just have my 4 is less than x here because I can't put less than or equal to, because that means I would have 2 included values at the same spot, and that would no longer make it a function. If I have something that's less than or equal to here, that means the other value can't be less than or equal to, it's just going to be less than. Now, what I could also do is I could actually end up switching these out, and this one could be less than 4, and this one can be 4 is less than or equal to, but conventionally, you're usually going to see the first one be written like this. All right, so next we're going to look at our third function here, the part where he ascends again, this time at a faster rate. So this is going to be section 3. This is a line again. This time it has a slope of 2 because we're going up 2 and then to the right 1. We may assume that our y-intercept is 4 because we start here at 10, 4. But that's actually not going to be the case, because if I was to rewrite this function, and extend this whole entire line here, we can see that y-intercept is actually going to be a lot lower than just 4, where it crosses our original y-axis. Since we don't know right now off the top of our head what our y-intercept is, what we can do easily to help with that is recall what we have above, which is this point-slope form, and just write our equation using that. Because we know our slope is 2, and I can pick any point on this line, either one of the ends or just a point in the middle, and use that as our point. Just for sake of things, I'm going to use the point 1310 because that's at the top of our graph here. And I'm going to use my slope of 2 and just write that in point slope form for my function. I'll have skip out in the first y equals part. So our slope, which we said is 2 times x minus x1. So x1 here is 13. Close the parentheses, and then plus 10. Now you could also go ahead and simplify that in slope-intercept form, but you wouldn't have to in this case, or if you have a question like that on a test FRQ, you can just leave it in point-slope form. Then we want to also go ahead and figure out the domain. So when is he climbing? He's climbing from 10 minutes to 13 minutes. So my domain here is going to be 10 is less than x is less than or equal to 13. So again, just like that last one, make sure we have one of our x values included, one of them not included. And in our last section here, section number 4, we're going down. And this time we're going to have a slope of -1 because we're going down 1 to the right 1. And again, we don't know what our y-intercept is here because again, this line extends all the way off our graph that we can't see it. So we're going to use point slope form again. This time I'm going to use the number 20, 3. We'll have y is equal to m, which is a -1, times x minus x1, which if I remember correctly is 20, plus y1, and our y value is 3. And then to wrap things up, now I have to write my domain. So we're going from 13, which is 13 is less than x is less than or equal to 20. Each one of these functions, which I have written here, represents each one of the sections that we have on our graph above, and that's how we would write a piecewise function. Onto some vocabulary to tie things together. We have the piecewise function and the subfunction. So the piecewise function, which was what we were just talking about, that's just going to be a function defined by more than 2 subfunctions, with each section existing in a certain interval of the function's domain. And then we have a subfunction, which is going to be a piece of the function. So we had 4 different pieces of the function, or 4 different subfunctions, and they each exist on their own specific part of the domain of our whole entire function, therefore making a piecewise function. So that's kind of how that all ties in together. So number 4 says, which subfunction would you use to algebraically find the value of f of 12? So what we would do is we would go to our piecewise function, and I'd look at the domains and which subfunction has a domain that includes the number 12. It wouldn't be the first 2 because that goes from 0 to 4 and then 4 to 10. It would be the third one because that has a domain from 10 to 13, and it wouldn't be the last one because that has a domain from 13 to 20. We would use the third subfunction because that value of 12 falls within that domain. We'd say subfunction 3. Next, we're going to find f of 12, and then we're going to use the story that we created to explain this meaning. So we can do this in 2 different ways. The first way would be using the graph. So using the graph, I would go to where x equal to 12, which would be here. And then I would find the y value that corresponds with it, which is here. And that would put me at the point 12, 8. So we know f of 12 is going to be equal to 8. Another way that we can do it is algebraically. And so I can just plug in 12 into my third subfunction. So that would be 2 times 12 minus 13 plus 10. So that would be 2 times -1 plus 10, which would be -2 plus 10, which also would give me 8. That's a way I can do it algebraically. What this means in the context of my story, this means at 12 minutes, LeBron is at 800 feet. And keep in mind here, I'm saying 800 feet because in the context of my graph, my feet is going to be measured in hundreds. So for this last one, we're going to find the following values, and we're going to go through this kind of quickly. So first, it says find f of 7. So I go where x is equal to 7 on my graph, which would be right here. And the corresponding y value that goes along with that would be 4. So f of 7 is equal to 4. Letter B and letter C are a little bit different though, because now it says f of x equal to something. And now we're trying to figure out what x value corresponds with the given y value. So now when y is equal to 2, what is x going to be equal to? So I go up to 2. My x value that corresponds here is also going to be 2. So I would just write this one as f of 2 is equal to 2. Same thing for letter C. I go where y is equal to 8. So up here, and I see, as we can remember from before, it touches it at x is equal to 12. But if we keep extending this line a little bit further, we see it touches it at another spot over here, and that's going to be at 15. So this time we have two different answers. We have f of 12 is equal to 8, and we also have f of 15 is equal to 8. So make sure you pay attention for multiple answers on some of these. And then the last one, find f of 13. Go where x is equal to 13. That's conveniently one of the points that we have given to us here. And that is going to be y is equal to 10. So f of 13 is equal to 10. And there we have a basic introduction on piecewise functions. I hope that you guys were able to understand the basics from these.